Good afternoon. In this set of tutorials, we're going to show how to convert an ODB file into an AWR layout so that it can be simulated. We're starting with a power amplifier. It's 8-layer board. The components are actually on the bottom of the board. We're looking at it from the top. And we're primarily concerned with the RF part. Over here we have the DC and control input, some regulators, but in here you can see there's different RF circuits and a variety of test ports to come in through connectors. That's what we want to simulate in AWR. To make the conversion, we're going to use Artwork's NetX ODB for Microwave Office, and we're going to import the ODB, and then we're going to select, say, a region to simulate and export that, and then import that into Microwave Office. Let's start by importing the ODB. We can select a file or directory. It happens to be stored in a directory structure. The top level is called R6PA, so we accept that. And then the data is copied into a temporary file and then scanned and imported. After bringing it in, we get a list of all of the different layers. There's a lot of layers in this design, but the ones that we care about are going to be the conductor layers, the component, and the drill. Let's select those for import. So those are the conductor layers. And then the component is important. You need that. And you need all the drills. This design has a lot of different drills. Through hole 1 to 8 here. You also see a 4 to 5, a 3 to 4, 7 to 8, a 5 to 6, a 6 to 7, 5 to 8, 6 to 8. This has a lot of buried and blind vias in it. If you were to try to bring this in by hand, it would take you days and days and days. The rest of the layers we don't need. So we just click import. It does the final processing of the symbols and gets everything all stacked up based on the matrix file in the ODB. So now we're in our main dialog. There are some things that we can do. We have some preferences. We can control things like the arc resolution and the chord error. The other thing we can do is we can define an extraction. That can be done two ways. In this tutorial, we're going to use a window. I want to select a region. I go to Define. It pops up our viewer and shows us the layout. Now we can define a window or windows that we want to simulate. So let's do that next. I want to select this region here and the connections from here and here. I can start by selecting that box. I can add another box to it. I can add this box here, and I could even add this area here. So I could add this box here. I can build myself up a polygon shape by adding and subtracting boxes. So that's the region that I've selected for analysis. When I'm done, I just click Finish. Now I'm back and it says one region defined. The final step now is to just run the program, and we'll be getting a 3DI file as our output. While it runs, it does a bunch of different functions. First of all, it has to unionize all the data on every single conductor layer. That's part of the net building process. If you take anything that's overlapping or touching and combine it into one polygon, you've essentially built yourself a net on that layer. Once it's processed those layers, it looks at the drills and creates vias between the conductor layers and uses those to continue assembling the nets. Then it builds pad stacks, computes all the nets, and finally it produces the output that we call 3DI. Now we're done, and what we'd like to do before we actually move over to the Microwave Office side of things, we're going to look at the 3DI file. We'll open the 3DI file. Let's rotate it around. You can see the components are on the bottom. If we zoom into the area that we care about, let's turn off some of the layers so we can actually see where the action's occurring. I've turned off all the layers except for M4 because that's where the connection from the connectors into the circuitry is made on M4. That's the pink layer. Then this other layer is the bottom layer, M8, and that's where the components are sitting on. You can see the components on this side. And this large component is actually a shield. However, the user created it as a component, and so we pull it out as a component. All right, now that you see what we've got, let's go on to the Microwave Office side of things. To bring the data into Microwave Office, you start a new project and then select the wizard called AWR 3DI Import. We have some options here. Since we did a window selection, we don't have selected nets, so we should use the layout only option. And then we'll browse and select the file we just produced. So all we need to do is click OK, and you can see that in just a second it brings up the design. The design is hierarchical, and this is probably an EM simulation. You can see that we have all of the conductors that we need. If we wanted to see this in 3D, we would go to View 3D Layout, and there it is. And you can actually zoom around in this guy and see that it's a full 3D model. That's a very fast way to get into your microwave office from any kind of a PC board layout, whether it has many layers, whether it has varied or blind vias. It's all supported. Thank you.